folks have already put up there. Things like an automated candy dispenser. We've got some robotics devices, some other camera-based devices using machine learning locally on the device. And so we'd like to invite you to visit that community, join the community, so that you can show us what projects you're working on, or just see some of the other cool things that have been put together there. And in that spirit, I want to quickly show you a demo of one of the projects that we posted on Hackster, which is what we call the Edison Candle. So this is an example, and I'll show you the code, and I've actually got the physical device here with me as well. I'll show you that in a minute. This device essentially is an example that application. The board schematics are open source on Circuit Hub. You can actually buy the boards directly if you want to play around with this. And all of this functionality is we've wrapped it up into a Hackster project so that you could kind of read through and learn how it all works. But the basic idea of this example is to kind of show you what it looks like if you were to build a production device. Right? A few slides ago, I showed you the Intel Edison Developer Kit, which was the same module on a fairly large board that had all of the I/O broken out for you to be able to work with it directly. This is basically a custom designed baseboard that strips away all the stuff that we don't need except for what specifically this application requires. And this application is a very basic application that just blinks a couple of LEDs in a flicker pattern to make it look like a simple LED candle. So it's a very simple example to sort of get started with, but because of that, we didn't really need anything on the baseboard except a way to connect to it and power it, and the two LEDs that we needed to blink. So we could create a much smaller, much less expensive to produce board that had all of those pieces on it and then sort of build an application around it. So I'll quickly show you what the software experience sort of looks like on this board. So I'm going to switch over to my demo here. So if you've never seen it before, this is Android Studio. And the Android Studio IDE is what Android developers use to build applications. And we are using those exact same tools when we're working with Android Things. So this application that I'm going to show you is written in Java, which is the primary development language for Android Things. We do also support development using C or C++ if you want to use the Android NDK. All of the peripheral I/O APIs are supported through that mechanism as well. And we just recently announced first-class support for the Kotlin programming language, so you can also use Kotlin to develop your Android Things apps as well. But in this case, we're just going to show you the sample here in Java. So again, if you're not familiar with Android development, I'll quickly just go over some of the things. The main component inside of your application is this thing called an activity. So you could think of this as sort of the main entry point into your app, and specifically the onCreate method of that activity. So inside of this application, when the device boots up, this application will automatically launch, or if we're just going to deploy it out of the IDE, the onCreate method of this code is what's going to get called. And basically what I want to show you is how simple it was to create this little example and what that code sort of looks like. So inside of the Edison Candle, we had those two LEDs, and each of those LEDs is connected to a PWM. And the PWM port, or pulse width modulator, allows us to basically vary the output value from 0 to 100%. And that allows us to control the brightness of the LED. So what this code actually looks like in practice is we're opening two connections to each of those PWM ports for the LEDs, and then we're running some code to actually vary the brightness to give that flicker pattern. So I'll give you an example of what that code actually looks like. So accessing the actual LEDs, or the PWMs, looks something like this. So if you've done Android development before, this API format will look very familiar to you because it's consistent with the way other Android APIs are structured. But essentially, there's some manager service, in this case it's the peripheral manager service, where we interact with that in our application to create a new connection to individual pieces of hardware and then control that pin or that port on the system. So in this case, we're using the peripheral manager service to open a new connection to that PWM, and then control some of the parameters around it. What is the frequency, and what is the duty cycle, which is essentially how often should it be turned on, and that's how we vary that value between 0 and 100%. So with just a handful of lines of code, I can open up 2 connections to each one of those LEDs, the yellow one and the orange one, inside of my application. And then the other interesting thing, and this is actually something we get for free from Android, is if I were to write this application in other lower level platform or maybe on a microcontroller, I would have to actually write the code that loops through continuously and adjusts those brightness parameters to get that sort of change over time effect that I'd like to see. But if you think about it, a change over time is essentially just an animation. And Android has a fully functional and fully featured animation framework that has all of those capabilities in it already. So inside of my application, if I just want to manage a couple of LEDs and change their brightness over time, I can use Android's animation framework to do that for me. So all I have to do inside of this code is create a new instance of an animation, tell it essentially how long to run, it needs to repeat forever, and this little thing called an interpolator is a way of defining what the path of the animation should be. So in this case, we're getting a flicker effect in our candle because of this interpolator called bounce that actually takes the value that it's animating and oscillates it a little bit at the end before it moves back the other direction. So again, with just a handful of lines of code using the animation framework, I can create these effects without having to write a bunch of loops and timers and other things along that line. Okay, so now I'll show you what this looks like running. So inside of Android Studio, I can click this little green button to run the application, and that will give me a list of all the devices that I have connected. So we can see that the Edison device that I have connected here over USB is visible. And so I can click OK, and once that application is built and deployed, I'll cover this so you can see it a little better, the LEDs should start to flicker in that pattern. So there we go. So now you can see that application running on the device, and it's a very simple application. It's just animating those 2 LEDs in essentially the same pattern, just offset from each other. And all of that with really just about 100 lines of code, most of which is essentially boilerplate for the framework. So there's very little code involved in getting this up and running with working with some of the basic peripherals inside of Android Things. Okay. Jump back to the slides here real quick. All right, so that's pretty much all I have for you today. Just a couple of final parting links here before we get into the Q&A. Other things that you can look at if you're interested in learning more about Android Things. One of the first places to go would probably be the developer documentation. So this is on the Android developer site alongside all of the other Android platforms I mentioned. So just developer.android.com/things. We'd like you to join our Hackster community, the Google Hackster community. So you can find that at hackster.io/Google. We'd like you to join that community as well as, show us what projects you're working on, look at the projects that are there, and sort of start to build that level of inspiration amongst the community. And then finally, we'd like you to join the IoT developers community that we have on Google+. And this is where other developers that are working on Android Things, but also those of us on the team are also in this community, so you can use it to share information, ask questions. We're constantly in there so that we can answer questions about, why is something not working. We also have a Stack Overflow community that you just tag your question with Android Things, and we can help provide answers there as well. So that's all I have for you today. Thanks very much for your attention, folks.
Dave, thank you so much. This was really good. I also learned a ton of stuff, and there's a lot of questions that I've been monitoring. I actually was able to answer at least one, but let me go ahead and start. And we have a bunch of time to answer. So let's see. Yeah, there's a question around Nest support. Will Nest support Android Things with Weave now? Will you have full control? So a little bit about yeah.
So Nest is an ecosystem of devices that are made by Nest or whatever. I mean, Android Things is a developer platform. It's not a consumer platform. So Android Things is designed for people to make their own devices, whereas Nest, they sell thermostats and cameras and things like that. So Nest has their own developer platform. If you want to control devices with a unified approach, then you'd use something like the Google Assistant with Smart Home. So that is the ability for developers to integrate their own light bulbs and things like that. And Nest integrates with the Google Assistant as well. So it's kind of, that's the correct approach to integrate Nest devices with a cohesive ecosystem.
Got it. Great. Okay, give me one sec. Can you talk a little bit more about your integration with your cloud offering, around something more about data collection analysis, context-driven triggering of functions?
Okay, so it's Cloud IoT, I imagine. Yeah, so basically Cloud IoT launched at Google I/O just recently, so there was a talk there about it. So if you want to actually learn more about it, there was an entire talk for like 40 minutes about Cloud IoT, so that was quite interesting. I mean, Cloud IoT runs on many different kinds of hardware. I mean, it can run on Android things, but it's not restricted to just running on Android things. It's designed for enterprise deployments so that you can, it's designed for when you've got millions of sensors that are scattered everywhere, and it's designed for easy deployment so that you can scale out 1 million devices really easily. So that's the main point of Cloud IoT. It's designed to do that. So Android things could be the operating system that it runs on, but it's not necessarily limited to that. It can run on many other things as well, because we understand that not everyone's using it, and so we wanted to make sure it ran on as many platforms as possible.
Great. Are you guys working on supporting more kits, more hardware in the horizon you can share?
There's always more hardware coming. I mean, OEMs are constantly coming up with new hardware designs or whatever. We don't have any exact plans to share today, but all the big device makers, that some of them have made announcements and press releases about upcoming devices, with LTE support and different things like that. So there is a whole bunch of boards coming, but kind of we don't want to comment about plans that are not available yet.
Now, I will add one thing to that, which is this is definitely something where we want to hear feedback from the community, sort of along what platforms you want to support and maybe what your needs are and why the platforms that we don't support aren't meeting your needs. So a couple ways that you could provide that feedback. One is you can post that information in the G+ community. And another is we'll be sending out an email following this webinar that will have a survey in it. And a lot of the questions in that survey are targeted around gathering feedback on hardware support. So if you have thoughts on that, look for that and fill out the survey as well.
Yeah, that's cool. I mean, we do have a wide range of boards for different kinds of people. Some have got good graphics, some are small SOM-based design. So we think we've got a lot of boards that do different things. So really would like to learn more about what people are trying to do and what their needs are and so forth, like Dave said.
Yeah. Awesome. RPI, Raspberry, is it only RPI 3 is being supported right now?
Yeah, so right now we only support the Raspberry Pi 3. I mean, there's a porting effort required to support every board, so it would take a lot of effort to support Raspberry Pi 1, 2, and so forth. And it's like the Raspberry Pi 1 and 2 are obsoleted by the Raspberry Pi 3, so we're mainly aiming towards newer devices because Android Things is a very new platform, so it's kind of by supporting really old hardware that you can't buy anymore, it's not a good investment of our time. We'd rather spend our time on adding new features to the platform and supporting newer boards that are going to be the future of this platform. So that's where we spend most of our time is on that. So yeah, the boards are really cheap, so it's better if someone buys a board that's designed for that specific application. Like we get a lot of requests at conferences for, hey, I've got this board sitting around, I'd like to port Android Things to it or whatever, and the cost of porting it is incredibly high, so in some cases it can be just easier just to buy something that works for what we're trying to do.
Makes sense. Talk a little bit about security. Are the devices being made secure in the field, in Android Things, and how? So a little bit about security in the context of Android Things.
Well, Dave talked a bit about it earlier, so I mean, one of the nice things about Android Things is that there's a big focus on security. So when the AB updates are being applied to the device, it checks the checksums of the binary package to make sure that it hasn't been tampered with along the way. Everything's done with HTTPS to make sure that there's no man-in-the-middle attacks and things. We have security updates from the Android team. So the same team that does the updates for Android also is making updates for Android things that we can push to devices. So we're covering a lot of those things. But also a lot of new hardware devices now are coming with crypto support on board. So it's possible to actually, for the device to prove that it's a legitimate device, so you don't have to worry about your hardware being copied and things like that. So there's actually at Google I/O, Darren Cran gave a talk about security on Android things, and it's a really nice talk that goes for about 40 minutes, where he goes through all of the details. I'm actually not an expert on security, and I learned a whole bunch when I watched that talk myself. And there's a lot of thought that's gone into it. As I said, like hardware on the device that is integrated into Android things, so you can do things like storing your keys in the crypto chip on board so that they're not visible on the file system itself. So there's lots of different things that we're doing to help you as a device maker ensure the authenticity of your device, to protect your customer's information and things like that. So it's really, and this stuff is difficult to do by yourself because the crypto chips tend to be not documented well or hard to access or require privileged access to get to them. So we've provided APIs and the support necessary so that you can take advantage of these things without having to be a security expert yourself. Because that's the other thing with building IoT products is that a lot of people think, oh yeah, I can build my own update mechanism or my own security, but it's really hard. And if you don't do it perfectly right, then now you've got a security vulnerability. And so we take care of a lot of these things for you that really helps to make it so that you can make a secure product without having to worry about all these things.
Cool, great. Another interesting question. Let's talk about machine learning a little bit, such as TensorFlow APIs. How does that kind of work with Android things?
Well, the nice thing, so a couple months ago, we did a blog post where we announced a sample that allows you to run TensorFlow on Android things. So we had this little demo that anyone can try out if they want, where you basically can point a camera at pictures of dogs and it'll identify the breed of them for you. So it's really cool because it takes advantage of the TensorFlow inbuilt image recognition engine that they've provided, and it recognizes animals and other objects for you, but it shows how it works on Android things. We showed how to make a device around it to make a cool demo. But that's one of the really cool things about Android things is its ability to run TensorFlow, because a lot of other microcontrollers, so for example, you can buy really, really simple microcontrollers, but they're simple, they're designed to blink a light or do something very basic. But the nice thing about Android things is you can run really high-powered things like image processing and audio processing and so forth. And that's where I think Android things is really going to show its strengths, is in areas like machine vision and learning and all these different things, because they require really high-powered CPUs. And that's one of the things that Android things is really good at, is providing that functionality. So I think we're going to see a lot of really exciting machine vision and learning type things coming out soon that are, it's going to be very interesting to see what kind of cool ideas hackers come up with, especially on the Hackster community, of crazy things that you can do with it. Like there's a lot of cool possibilities.
And kind of along those same lines, Wayne mentioned that we did publish a sample of using TensorFlow locally to do inference on an Android Things device. So you can find that by just going to the Android developer site and looking up our samples. But one of the Hackster projects, it's actually one of the ones I featured on the slide, the wildlife detector, actually was based off of our sample and does the same sort of thing. It captures images of wildlife that come by and analyzes whether or not it's a certain type of animal based on the local machine learning model that's running TensorFlow. So you can look at that one on the Hackster community as well and kind of get a feel for how people are using that today already.
And it's really easy to take the sample and modify it and do whatever you want. So if you've got some crazy idea, then definitely you can take that sample, tweak it, and turn it into something like that. So there's a lot of, it's going to be very interesting to see what people put together with it.
Cool. There's a question that repeats itself a lot. Obviously, everybody wants to understand how you guys are going to handle the Edison and the whole Intel situation, and I'm assuming you're going to keep supporting the products because these products are still fine and they're going to have a life cycle probably for several years. So I don't see this as something that's going to be dropped immediately, but why don't you guys give us an official response, like how are you handling the discontinuation of the Intel product line?
Yeah, so we support all the Edison products right now. So the developer preview of Android Things has been supporting Edison and Joule and so forth. So we're still working on those ports for Android Things as well. Hardware makers, they sometimes cancel products. That's part of what happens in the electronics industry. But every OEM is constantly releasing new devices as well. So there's a whole bunch of new boards coming out from different companies that Android Things is going to support. So I don't know, Dave, do you have anything to add?
I guess the only thing I would say is that, and we don't have anything official to announce here. We're still working with Intel, but the end of life of a hardware product doesn't necessarily mean the end of the software support for it. So just because they have issued EOL notices at the end of this year for the hardware, that doesn't necessarily mean that we can't continue to support that platform with our software on into the future. Now, what that actually looks like and how long that might be, we still need to work those details out, but that doesn't mean that at the end of 2017 you won't be able to flash Android Things on an Edison anymore.
Yeah, I think manufacturers, good manufacturers, this is how they do business, is they issue end-of-life statements when they're finished thing. It's a heads up for makers so that they're not caught out, planning a 5-year or 10-year production run, knowing that a device has been cancelled. So the really good manufacturers will always tell you their timelines to make sure that you're aware of what's going on. But sorry, but yes, it's part of how things are. But we're going to support it still. So as part of the preview that we're doing, we're still supporting these boards there.
Great. Technical question: your capability to talk to Shields or Mezzanine?
Sorry, what was the question?
Is there like a UART capabilities to talk to?
Oh, UART. Is there a UART?
Yeah.
Oh, yeah. So I don't know which boards support it, Dave. Do you know?
All of our boards have UART support. Yeah. So like the Edison, for example, right now the developer kit for the Edison is in an Arduino form factor. So you can mount shields on top of that, and the Arduino pinout for the UART, sort of on those first two pins, is mapped to that appropriately. So, if you have Arduino shields, they would work with that kit. Some of our other kits, like the NXP kit, is based off of the Raspberry Pi form factor. So the pinout there matches the Raspberry Pi 3. And so again, UART support is in the same place. If you have a hat that would go on top of an RPi, you could use it on the RPi or even on the NXP kit. And those are all plumbed into the APIs so that you can use them.
That's the thing, and if shields are important to you, then there's a couple different options you have to choose depending on what you're trying to do. So that's the nice thing, is they're available if you want to use them.
Yeah, cool. There's a good question here. Are you going to include an app so there will be a way to have a remote display which will assist you while you're developing?
That's something you could build yourself if you wanted to. It's just an Android device. We don't have anything plumbed into the framework itself to do remote display. But because it's Android, you could, if that was important as part of your application, and you wouldn't necessarily build a remote display. You could use something like Firebase, for example, to synchronize data to another device like a phone or a tablet. So it depends if it's for debugging or if it's part of the actual application experience itself. You do have a couple options there, but we don't provide anything in the framework itself to do that.
Yeah, and the other thing that I would say there is if it is, in fact, only for development purposes, many of the developer kits do support displays. For instance, the Raspberry Pi has HDMI, you can plug in a display, or even the NXP kits have display connectors that you could connect a small LCD to as well. So if you just want to have a display while you're doing development, then maybe you don't pin that out on your product. That's perfectly fine. And at that point, it's not even a remote display. It's just the display, and you can write data out to views if that's easier for debugging or however you want to work it.
Got it. Do you support client-server side web sockets?
As in, you want to run a web server on the device?
I guess, yeah.
I guess so. You can, because it's Android, whatever you could do in Android itself, you can start up a socket. You would have to provide your own web server, though. Android Things doesn't include a web server on the device that you can just add files to. So if you want a web server, you would need to provide the code for one and then start it up and do whatever it is that you're trying to do. So you could do something like that. It's mainly meant for running code on the device, and then you would connect to other servers on the cloud or whatever. But there's no reason you couldn't do something like that if that's what you're trying to do.
Yeah, and I guess I would add on to that by saying that we're not necessarily restricting communications to any specific type. It's not like Android Things will only communicate to the cloud through Firebase or Cloud IoT. You know, any HTTP API that you could connect to from your Android device, you can write the code to connect to from Android Things, including potentially even running a web server if that works for you. So it's the flexibility is there to connect to whatever services make sense for your app.
Cool. Other question are, let's see, a lot of Nest support questions, so we can answer that and we'll elaborate more on the Hackster site. Just question about your release cycles. What version are you on right now? Is it still a beta, right? When are you planning to release the second version, or
yeah? So I mean,
kind of roadmap.
Yeah, so we do developer previews every roughly 6 weeks or so. It varies depending on what we're doing. So we've been doing those. Now at Google I/O, Venkat Rapaka gave a talk about the roadmap for Android Things. So that's a really good talk if you want to learn more about what the planning is and so forth. So right now, the current plan is that Android O is coming soon for phones and tablets, but the next developer preview of Android Things is going to be based on Android O as well. So the engineering team right now is busy sort of porting everything over to Android O because Android Things is going to be sort of moving along with Android O now, so they need to get that in sync. So that's what they're working on right now. We don't have an exact timeline for when Android Things is going to go full stable that you've got to make products, but it's coming soon. Venkat talked a bit about the timeline in his talk as well. So sort of that's what we're working on right now is just getting ready for Android O. There'll be another preview based on that. And then the main goal is to sort of make sure we get all the features of Android in there so that the platform supports everything that people want. And then at some point we'll have our long-term support version coming soon, but we don't have an exact date for that yet.
And just another thing to add on to that, both the Venkat talk that you mentioned as well as Darren's talk that you mentioned earlier, both of those sort of touch on the long-term support. So once we do go into stable, how long we will support each version with security updates, et cetera, they describe what the plan is there as well. So it'd be good to watch those talks.
Cool. So, there are a lot more questions. So for everybody that did not get your question answered, I apologize, but please do go ahead and I will share it once
We'll be happy to answer them, on your forum or whatever, because at least that way the answers are for people to see. So, we'll go through them later on and put answers as best as we can.
So I just shared for everybody, here's the link. You can go see the project, and you can actually stay on the Google feed over there and ask all the questions that you need to be answered. There's a lot more questions again about Weave and even deeper questions about Nest. And but I'll do let's do one last question, and then we'll wrap it up. So because it is 10. There's some question about OTA, over-the-air updates. With Android Things, and let's see. So maybe just mention how you're planning to support over-the-air updates, if at all.
Well, it's the same mechanism that we use to update, Nexus phones or whatever. So it's sort of Google has an update infrastructure that we use for that. So we can push updates out to devices. The Android Things developer console is where you go about building those update packages to push to the device. So you upload a zip file that contains an APK, which has your user code in it, along with any extra little bits and pieces. You then upload that to the console. The console then builds a system image or whatever that is then pushed to the device via the OTA mechanism. So you don't have to worry about OTAs. That's the nice thing about it, is that it kind of handles everything. So a lot of people try to build their own update mechanism that has security vulnerabilities and all kinds of problems. We handle all that. It's a mechanism that's been, tested for many years and used by Nexus phones. So it's kind of a very nice way of pushing updates to the devices. And then, as Dave mentioned earlier, it does an A/B update mechanism similar to what is currently on Android N, so that you can stage the next update, reboot into it, and then if it fails, you can roll back to the previous version. And then it makes sure the device always comes up cleanly, and if there's any problems, it goes back to the old version to make sure that your device is never stuck in a brick state where it can't boot and get further updates. So, yeah, I mean, that's basically the system's pretty simple in concept. So yeah.
One thing that I would add to that, just to be more specific, is that if you're familiar with being an Android app developer, when you ship an app update to the Play Store, there's an app on the device, the Play Store app, that downloads the new version and updates that specific APK. This is not how that works. This is more like when your entire operating system gets a new version update or gets a security update, where the update is actually downloaded and the entire system is patched into the new version. This is that mechanism, not updating just your app like you would as a Play Store developer.
Right. Cool.
Well, I guess one final thing, Wes. You mentioned, there's a bunch of questions about Weave and stuff like that, so I'll just say something quickly about that. So, I mean, in the past, Google was working on Weave. So, with I/O, we announced a whole bunch of new initiatives. So, we announced Cloud IoT, we announced Smart Home, which is the ability to connect devices into the Google Assistant. And so, between Android Things, Cloud IoT, Firebase, Smart Home, and so forth, we kind of have enough coverage of all the different things that we need to build an IoT ecosystem of devices, both for consumers and developers. So what's going to happen going forward is that Nest, who also has Weave as well, Nest is going to go forward with doing a developer story for Weave, but that's going to be something that Nest takes on from now on. So in the past, it was sort of worked on the Google side of things. As a result of all these other things that we have, Nest is going to go forward with Weave. We have enough other software APIs and so forth that can take care of everything that developers need. So I mean, that's mainly our strategy right now. So Nest going forward is going to have more information about Weave. They haven't said too much yet. That's coming soon. But yes, that's currently where things are at with Weave right now.
Cool. Well, great, Will. Thank you very much, Wayne and Dave. This was really informative, really good, very thorough. So thank you, everybody who joined the call and joined the webinar. As I mentioned, this webinar has been recorded, and we will follow up with a survey and a link to the recording. In the meantime, please do move your questions to the feed on the Google Hub on Hackster. And once again, thank you, everybody, and enjoy your weekend.
Cool. Thanks so much.